Anytime.
Okay. Hey guys, today I want to talk to you a little bit about screen mesh. My name is John Kupka and I'm with SAATI. We are a worldwide screen mesh manufacturer. And I want to share with you a little bit about some of the products that you use, namely the mesh, maybe the one you take the most for granted. The only reason we use screen mesh and screen printing is to hold our stencil together. If we could get a stencil to stay on the screen without the mesh being there, none of us would have any problems anymore. But since we do, I wanted to tell you a little bit about how this product's made and some of the applications and how you might use it a little better in your shop. Let's start with the mesh composition. I've got a couple of pieces of our mesh over here, and I know you won't be able to see this, but what we do at the mill is we will take these little teeny tiny threads, about this big. They're made out of polyester fabric. It's 100% polyester. And somehow these guys get these polyester threads to line up evenly and hopefully evenly spaced all the way across the weaving loom and weaving process. These threads are a specific diameter. So here's one of your variables in screen printing. We measure the thread diameters in microns, and that's a very small unit of measure. For example, the average human hair is about 75 microns. The thread that I have here in my hand is 48 microns. So it's not quite half as thick as a normal human hair, but it's very small. So you can imagine how difficult it is to get these threads to line up. In the weaving world, we have two directions of threads. We've got what we call a warp direction and a weft direction. And the best way that I can help you remember that is when you're looking at a roll of mesh, like we have on the front here, and you're looking from weft to white, you're looking at the weft threads. So all the threads that run this way are your weft threads, and all of the threads that run this way are your warp threads, and that's how the mesh is wrapped. We get these threads to line up in both warp and weft directions, then run through these great big heated rollers and press them together to create a solid piece of mesh. Otherwise, this would just be a bunch of threads flopping all over the place. This mesh is then dyed either yellow or some variation of yellow and sometimes orange that you may have seen in the industry. But all mesh starts out white, and we'll get back to the mesh color selection here in just a couple minutes. Once we have the fabric, this fabric now has all kinds of new properties to it. We have the mesh count, which can be calculated in metric or English units, centimeters or inches. And that's basically just your threads per inch. So if we're talking about a 110 mesh, then you'll know you have 110 threads before it's stretched per inch. If we're talking about a 305 mesh, that's 305 threads per inch. So we have mesh counts. And then the threads that we use, those little teeny tiny threads, we have a selection of a lot of different threads. And so then your next portion of this product here is you have thread diameter. So you have mesh count and thread diameter. This particular piece that I have here, as noted on the end, is our 230 48. So it's 230 threads per inch, 48 micron threads. Now, when we take these threads and we kind of jam them together with that heat to make this into a piece of fabric, we get what's called fabric thickness. It's another one of our controls that we have in screen printing. So fabric thickness combined with your mesh opening, we line these mesh threads up, there's an open space in between that gives you a little square opening. At least the high quality mesh has more of a square opening. So we can take all these things and put them in our toolbox to control the printing parameters that you deal with every day. Once we have the mesh, we get them out to our end users or screen makers, and basically they'll just take this product here, the screen mesh, and stretch it with a pneumatic or mechanical stretcher, glue them onto the screen frame, and this is what you're used to seeing all the time. So keep in mind that we still have those parameters on here, but we've introduced a whole new one called tension. And with that tension, we have things like stabilization rates, elongation rates, lots and lots of really complicated stuff that we can control from the screen making standpoint. But that's a whole nother topic for a whole nother time. What your job is, once you have the screen, is somehow to produce a printed product. And whether that's on a t-shirt or on a flat substrate, maybe it's on some sort of vinyl or paper or what have you, you can start to take all these variables and all these things that go into making the screen and use them to control your process. So I mentioned earlier that we were going to come back and talk about a couple of different topics that you can put in your toolbox and use daily. One is mesh count selection, and the other is mesh color. And we'll spend the last little bit of this sequence talking about the differences between mesh counts as well, and why select certain mesh counts as well as why select certain colors. As I mentioned before, all mesh starts out white, and then we dye it, and there's a reason we dye it. The reason is white mesh acts as somewhat of a fiber optic presence in your screen. So let me give you an example here. I've got this nice white screen, and I'm going to put this in my exposure unit and shoot an image. When the light starts to hit my film positive and my screen while it's in the exposure unit, it's actually going to bounce off the white mesh because white reflects every color in the visible spectrum. And the color of light that you need to expose your emulsion lands on the blue side. So that blue light that's coming in, exposing the emulsion, creating your stencil, is actually getting through and starting to bounce off and reflect off of white mesh. Now, if you're using printing a large block image or something with heavy coverage of ink, it might not be an issue, and it probably doesn't matter. But then when you get into these low lines and these little tiny halftones, would be a good time to consider using yellow mesh. Typically, you'll find more of the dyed mesh is in the higher mesh count range, which means higher mesh count and smaller thread diameter. Gives you a smaller ink deposit. Now, when you're looking into printing high detail images, you don't necessarily want a lot of ink to transfer through and start smearing everywhere. So use your mesh to control your ink deposit. Pick the color of your mesh based on your design. So the finer the design, the finer the halftones, you would want to jump up into mesh counts of 230s, 280s, 305s, depending on the ink laydown that you want. But this yellow mesh is going to absorb, remember all that blue light that we had coming through and reflecting off the white mesh? The yellow mesh is going to absorb mostly blue, because on the opposite end of the color wheel from blue it's more of a yellow-orange color. But we can absorb so much of that blue light where we're just exposing the emulsion, not bouncing the light off to undercut the image. So, general rule of thumb, finer designs, use your higher mesh counts, lower thread diameters, that'll give you more detail, more clarity on your edge, as well as yellow mesh. Now, back to the white mesh, and typically heavier thread diameters. This, as we mentioned before, creates your overall mesh thickness and your mesh opening. And that's going to be your control for things like underbases or printing on, if you're garment printing on dark materials, or where you generally want greater opacity. You want to drop your mesh count and raise your thread diameter to create or to have an available space that allows more ink to go through. The last fundamental principle that you have with your screen is screen tension. And these are all the basics of the screen making process. Screen tension, you also want to make sure that you got a relatively high screen tension. That's going to help you with ink transition transition as well as registration throughout the print run. And that's all I have today. I hope you've enjoyed and learned something and can take it and use it to improve your process.